Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Julie Tomei, and I am joined by Dr. Elena Hyde. Hi, Elena.
Hello, everyone. Very excited to be here now that we're on our way to podcast as well.
Huzzah! We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada, and soon from wherever you get your pods. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 1 a.m. Universal Coordinated Time. The York Universe podcast works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 and 10 p.m. local Toronto time. You can head over to www.yorku.ca/science/observatory and follow the links to OPV for online public viewing and join the chat there. For any questions or comments you have about past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. We can also be reached at our socials on Instagram. Our handle is at York U Observatory and Facebook at Allan I Carswell Obs. All of our programs are free, but if you would like to make a donation, please head over to that website, www.yorku.ca/science/observatory, and find the button. Um, we will be monitoring the chat room for questions to post content. The weather is clear.
Yeah,
The
pretty much.
Yeah, the telescope is open.
Yeah, totally.
Yeah. There will be images from the telescope uh in public viewing. What else? There's a lot happening at the observatory tonight, Elena.
There is. We are multitasking like you folks would not believe. We've got, of course, student observing happening for exoplanets. We've got the OPV running. We're doing York Universe. And of course, the class students are in the Zoom room with us. So it's been, I guess, triple duty for the observatory tonight. Very, very exciting stuff. Oh, and I should give a little shout out to Ryan Marciniak, who is actually currently right now logging in on the computers at the astronomer in residence out at Killarney Park.
Nice.
So if
Lots
he
of
joins
observing
Zoom too,
happening.
well, yeah, we'll be completely astronomered up. But I wouldn't expect him to be in on his first night.
Amazing. Okay. Shall we jump into things?
Yes. So other than there being pretty clear weather all around, we've got all kinds of great stuff scheduled for people. And I think that this week in space and astronomy history will be our usual good start. Now let me just see if I can turn something on without messing anything up here. We do have, as I mentioned, our astronomer in residence out at Killarney Provincial Park. And we're actually working on sending them the full unabridged YouTube video playlist so that they can was it I think take off the domes. So a little bit of
Oh, yes.
yes, exactly. A little bit of action happening. The if you haven't been out to Killarney Provincial Park this summer, or maybe even not any summer, the domes out there in the park are very different from the domes we have on campus, and not just because we've recently renovated. They're kind of plastic domes, and you actually have to take the lid off one piece at a time, as it were. Now,
I
here
love
at
those domes, but they do feel like a kid's play set.
and a two-person job, really.
Hmm, hmm.
I know folks who can do it one person, but I actually always grab a second person to help me when I'm taking those domes apart. So apparently, the Killarney site in Ontario, which is a 4 or 3-hour drive, depending on who you talk to. um, they have crystal, and I'm quoting Ryan here, crystal clear skies tonight.
Oh, amazing.
Uh-huh. So we've got fair skies here in Toronto, but as I'm sure many of you have noticed with the light pollution and various other factors, it makes it really a challenge to see dim objects. Very, very bright objects are not such a problem. And this, of course, includes things like the moon,
Hmm.
which will which will actually get me to our first This Week in Space and Astronomy history.
It sure will.
The moon is an excellent thing to try to view all over, and if you're out at the moment, you'll see it looks almost full. It's 98% full tonight, and tomorrow it'll be even better.
For a
The
few
moon,
reasons.
yes, for a few reasons, which I believe is one of our news items.
Yes, we'll
So
get there.
the moon has captivated humans for forever, I think. And in 1959, it was even more captivating because on the 14th of September, which is 2 days ago, back in 1959, we had a moon landing. And not just any moon landing, we had the Luna 2 moon landing, which was the very first moon landing by anything and the first landing of human things, not humans, but robots, on any extraterrestrial body. So the first time we had actually put something on a surface that was not Earth, as far as we know. So this was quite the event, and the Luna 2 mission was a groundbreaker in many ways. It didn't really break ground on the moon, but it certainly landed with a thunk. Um, it was originally named, and this is true, second Soviet cosmic rocket, and nicknamed Lunik 2 in media, basically. And so now we tend to refer to it as Luna 2, and it was, of course, launched to the moon. So the official launch date was the 12th of September, 1959, and then the epoch was a little bit different, and the impact date was the 13th of September, or the 14th if you're in Australia. So the Luna 1 was obviously part of the same program, but Luna 1 did not have, quite as good luck. It was Luna 1, as you might gather a little bit earlier on, it was the first one to reach the vicinity of Earth's moon. So it didn't land. Um, but it did go into a heliocentric orbit around the solar system. So, um, that's a goal of a kind. It was actually intended to impact the moon, but it had a malfunction in its control system. So, Luna 2 was, the one that actually made it, and Luna 2 being, a little bit more successful, and the first was an amazing accomplishment. And it's just interesting to think that through all the many tens of thousands of years that we've been watching the moon's surface. And this was the first time we actually managed to send something to the moon in 1959, which is either really long time ago or not that long at all, depending on how you think about it. If you want to try to find where this landed, it's in an area of the moon called the Mare Imbrium, which you you know, can make out if you are on, the correct sort of area, and you've got a full phase of the moon, for example, that will definitely help. So Mare Imbrium is basically a vast lava plain, and all the mares on the moon, those are kind of the dark, I would call them dark, shiny areas of the moon. And they tend to be kind of what make up the eyes of the man in the moon, I suppose, would be one way of looking at it. And it makes them easy to find.
Mhm.
So Mare Imbrium is visible to the naked eye from Earth, and
Yeah. It's the big round
um,
one in the middle at the top.
yeah, And if you're looking at the moon from the northern hemisphere, so keep in mind if you go to the southern hemisphere, the moon will appear to be upside down. But if you're looking from the north, and you've got the traditional man in the moon image, the mare imbrium is the man's right eye. So you can see it yourself. You don't have to take my word for it. Go out and have a look at the moon. It is up there. The moon tonight is just rising actually, and it's on its way to being about 20 degrees above the horizon. So it should be pretty visible, even if you're in downtown Toronto, for example. So Luna, 2 and landing on the moon for the very first time, these little sturdy Soviet spacecraft that made up the Luna mission are really, really interesting because they did actually a lot of them. I was looking at the Luna program and I sort of lost track around Luna 18. Um, but they actually generally carried pennants, which are the little flags sort of flown. They had very simple, well, what would be considered very simple kinds of instruments today, but they had what are called scintillation counters to measure radiation. And this is one of the ways we found out that without an atmosphere and a magnetic field, the radiation is actually kind of a problem. So the first indications that humans on the moon might have to watch out a little bit. And so that was all part of this Luna 2 mission. And if it's still there somewhere. So if we do ever get back to the moon, this is one that you can go look for. It does have mercury oxide batteries, so perhaps watch out for old mercury oxide batteries if you do ever get there. But it's a great mission, really a moment in history. It took a direct path to the moon, so just shot up from Earth, and went sort of straight up, and the rocket was actually also called Luna. So this was part of the same, I guess, mission profile. And this was the Luna 8K72 carrier rocket. So if you're a big rocketry fan, they were actually derived from earlier designs, and it's kind of a really cool design. It's got a little bit of a honeycomb inside. That's what it reminds me of. Anyways, it made it. It shot straight up. It went straight to the moon, and they hit the moon, and it was a success. So Luna 1 didn't make it, but it got into orbit around the sun, so great. Luna 2, they were actually able to calculate when it would hit its mark on the moon, and they announced it on Radio Moscow, of course, and it basically traveled straight there. And this was also one where we were able to make use of some local telescopes. So what are so-called small telescopes today were pretty big telescopes at the time, and they actually contracted the Jodrell Bank Observatory in Cheshire, England, which is a radio observatory. And Bernard Lovell at that observatory, he actually observed the transmission and trajectory details and was able to confirm that the radio signal coming from Luna 2 by showing the Doppler shift from its transmissions. And so they were able to actually confirm the Luna 2 landing with a radio dish looking at Doppler shift from its transmissions in England. And they tracked it about 5 hours before it struck the moon, and they actually could record transmissions from the probe, which obviously ended as soon as it hit the moon. And he played the recording during a phone call to reporters in New York, and that convinced the media that the mission had really happened. So it was a
Mm.
very obviously interesting time, lots of interesting stuff going on, and there was some pretty cool science looking at lunar magnetic and radiation fields, looking at the energy spectrum, and measuring, I think for the first time ever, actual real solar wind flux, because we could never measure it before. Our Earth's magnetosphere protected us too much. Cool mission, really, really fun. And of course, the moon.
Yay, moon.
Yeah, and I mean, this is arguably the one that got us all started right here.
Yeah, I was thinking like this must have like I know Sputnik is looked on as like the official start of the space race, but I imagine this stoked some fires.
Yeah, and especially confirming internationally that of course the Soviets had the first lunar landing that humans have ever accomplished. I mean, that had to have been just major news at the time. And of course, I will say though that this moon is probably, it was the easiest target we possibly could have gone for. It's
Yes.
literally right next to us, and it was still this hard to get there.
Well, if, as we've said many times before on our program, space is hard.
Yeah, well, and it really gives you some appreciation for missions that have made it to moons around other planets.
Yes. Let's get to one of those.
Let's get to one of those, indeed.
No, it's not a mission that made it, it's a discovery because you got to discover the thing before you send a thing to it. Uh,
Usually.
yes, usually, hopefully, right? Because if you send a thing to it unexpectedly, you've spent a lot of money to crash the thing. Um, so we're going to September 17th, 1789, and the discovery of Mimas, also known as Saturn 1, because it is the closest moon to Saturn. It was discovered by English astronomer William Herschel. It's the seventh largest moon of Saturn. And in Greek mythology, Mimas was a giant who was killed by Mars in the war between the Titans and the Olympian gods. His legs were snakes, and even after his death, they hissed and tried to attack Mars. The name was suggested by William Herschel's son, John, who explained his idea for naming the moons of Saturn thusly, quote, as Saturn devoured his children, his family could not be assembled round him, so that the choice lay among his brothers and sisters, the Titans and Titanesses, end quote. From the ground, it looks like little more than a dot. So we didn't get, good images of this moon until the Voyager 1 and 2 space probes imaged it in 1980. And then we got really good data and images when the Cassini spacecraft made several close approaches in the mid-aughts.
Yay, Cassini.
Yay, Cassini.
Such a cool mission.
Yes. The mean radius is about 200, a little less than 200 kilometers. It's covered in craters. It's somewhat ovoid in shape. It's kind of at that bottom uh, threshold for having enough mass to make itself almost spherical. Um, so its dimensions are approximately 207 by 197 by 191 kilometers. It's
Yeah,
roughly spherical.
I think that is the scientific term. It's round-ish.
It's round-ish. We can safely approximate it to be a sphere to make the math easier, I think.
Well, I've
Um,
I've seen cows approximated as a sphere, so this is no problem for
exactly,
me.
exactly. It's low density, making it probably mostly water ice. It's the only substance, water ice, the only substance that's ever been detected there. Like our moon, it's tidally locked, so the same side faces Saturn at all times, but it orbits much faster than our moon. It orbits Saturn once every 22 hours, 36 minutes. It has so many impact craters. Some are as big as 40 kilometers in diameter. Craters in the South Pole region are generally a little bit smaller, about 20 kilometers in diameter or less. So, probably some melting or resurfacing happen there later than on the rest of the moon. Its most recognizable feature, however, is a giant impact crater named Herschel that covers a third of the face of the moon and probably had the scientists thinking that's no moon when they first the images were first returned from the Voyager spacecraft, as it makes Mimas look like the Death Star.
Well, that's actually going to relate to our news item later about the our moon. So wait for
Yes.
it.
Yeah, wait for it. Uh, the Herschel crater is really big compared to the other craters. It's 130 kilometers across. Its outer walls are about 5 kilometers high and it has a central peak 6 kilometers high. The impact that created it probably came close to destroying the moon, and shockwaves from it likely caused this fracture feature called chasmata on the opposite side. Mimas has an elongated orbit and it gets more tidal heating than Enceladus, but it's frozen solid, whereas Enceladus has geysers of water. So it's a little bit strange. As a result of this, there's something known as the Mimas test. Any theory that explains the partially thawed water on Enceladus also has to explain why Mimas is frozen solid. Good
Ooh,
test.
spicy.
Yes, good test, I think.
Yeah, yeah, that well, and I mean they're absolutely right. It is how do you get a more solid surface with more tidal heating?
Mm-hmm. I mean, Saturn has so many moons,
Yeah.
and so many of them are so interesting.
Oh yeah, and I mean we just have not been to Saturn enough, but also Neptune and Uranus, and there's so much cool stuff out there.
Yes, I've got my fingers crossed for Uranus.
And the fun thing is as well with these icy moons, you do tend to get more interesting features. I mean, we're used to things like mare and craters on our moon, but they've got sharp relief features, kind of deep depressions. As you say, this really interesting Herschel crater. Um, strange tidal forces happening, just all kinds of great stuff.
Yeah. And I mean, it's the other thing I find interesting is like, it's like a solid chunk of water ice
Yeah, and I mean, maybe it's not a moon. Maybe it's just a really, really big comet.
just got stuck there.
Yeah, just got stuck there. But now I'm just making things up. That's all right. Don't worry, folks. I do not know. We're just taking complete theories here.
Yes.
But
But
yeah,
this,
it is interesting that the only thing they've detected is water from it. Um,
yeah, so cool. So, you know, every time you hear about someone saying, oh, yeah, well, after this mission, science will be done,
no.
whatever.
It's that is one of the great things is everything you do to answer questions generates more questions.
Yes,
It's like, oh, I'm pretty sure we could do this forever and still have just as much fun.
absolutely. Absolutely. This is why science is awesome.
And what of them? Well, you have to like mysteries just a little bit, because of course, Mimas is a wonderful mystery, and especially like you say, as it is so unusual in appearance and composition. Uh, and of course, there are still things about our own moon that remain a little bit of a mystery.
Hmm. So,
So that gets us back. So
to our moon.
I'm going to go a little bit more recent and go all the way to 2007 because there was actually this really fun mission that was put out by Japan that I hadn't read a lot about and I wanted to find out more. So there was in the 14th of September 2007 there was something called the Selene or Cayuga, or sorry, Kaguya mission. I better at least try to pronounce this right. Not get too confused. Kaguya was the nickname, and the official name was Selene, but you'll almost always see it written as Kaguya pretty much everywhere. This was a Japanese mission and basically went to our moon. It went to our moon and deployed two satellites named Okina and Auna. And the Cayuga itself, or Selene, actually impacted the moon at the end of the mission. And the Okina satellite also impacted the moon. So up in 2007, we've got one mission which splits into three components, and two of them impact the moon. The Auna basically stayed in orbit and completed operations in 2009, but it actually has a pretty cool end of life plan is that it actually has stayed in what's called selenocentric orbit. So it's kind of stayed near its parent, shall I say. And this is a Japanese lunar orbiter spacecraft was the original plan. And this was actually following the Hiten spacecraft, which came before in 19 shoot, when was that? Just a few years before this one happened. I think it was 2005 or something it launched. And the missions all in were all about exploring the moon. So Cayuga and its sort of satellite pieces, shall I say, the deployments, you know, basically all went together. And the three separate spacecrafts were you had the main orbiter, and then the Okina was a small relay satellite, and Auna was the what's called a VLBI or Very Long Baseline Interferometry satellite. And this one was really interesting because this was actually a backup method to map the moon's gravity field. And this is really interesting because our moon doesn't seem to have an even distribution of mass all the way through it. We know that it's cooled down, but it's not true that the mass is like an even ball of clay all wadded in. It seems to have a bit of a um, shall I say, mass overdensities and underdensities. So mapping out the gravitational field will mean that you can very accurately predict things like how much acceleration is the gravity of the moon going to give you, and that kind of stuff. So one way you can use it is at what's called the lunar limb, through the visible edge of that surface. So when the moon has its phases, you have the visible side that's lit up and appears kind of white, and then you have the rest of the moon that's in shadow. And if you can see it at all, it's very, very dark. The lunar limb is that edge of the visible surface, and this is also called sometimes the terminator line, and this is where you get really, really good shadows, and you can make out a lot of detail on the craters if, for example, you're looking with your naked eye. So really fun stuff. Lots and lots of science in this one. They really combined a whole bunch of different science areas, all in with this three spacecraft combined super duper orbiting machine. So Okina was the relay satellite, and it had uh, a relay for radio communications between the orbiter and Earth when the orbiter was behind the moon. And this also helped with Doppler shift measurements for the gravitational field of the lunar far side. The relay satellite impacted the lunar far side near what's called Minor D crater, which is a large impact crater that you absolutely cannot see. So unlike the other one that you could view because it's on the Earth-facing side, this is on the lunar far side. So from Earth, you will not be able to see it. You need to launch a spacecraft and go around the backside of the moon to be able to actually view this one. But if you do that, you will be able to see this impact site, provided that you bring a telescope or something. um, so Cayuga had, basically 15 observation experiments, and they were able to complete all 15 within basically the first couple months. So they had a fabulous successful mission. They had planned to go for about a year, and then they extended for 2 years. So it's not as long as some of the missions we've heard of, but it did very, very well and still made it past its originally estimated lifetime. It did eventually have to, you know, be deorbited and crashed into the moon on purpose because it had a degraded what's called a reaction wheel, which are the little wheels that cause the spacecraft to be able to rotate and change its speed. And so this means that they were not sure that they would be able to accurately control it. Rather than letting it run loose across the solar system, they decided to set it down someplace where they'd be able to predict where it was going. And that was the end of that. So obviously, once it crashes on the moon, it's pretty much done with its mission. But they had major results. They had lovely, lovely lunar global topography maps, which you can actually find. They were published in Science. Altitude, so how high various peaks and troughs were, and this was actually used in Google. So this is Google Moon got this for free. What a deal. And so if you go to Google Moon to make Google Moon 3D, that's what you're seeing actually. So if you don't want to go to the original science article, it's actually pretty easy to get to. We also have, of course, the detailed gravity map of the far side of the moon, the first optical observation of some permanently shadowed craters, which is where we've heard these interesting things about water ice on the moon not so long ago. So this includes the crater Shackleton at the lunar south pole, which is now a hot destination, cold destination.
A cool
um,
destination.
and finally, evidence of Earth's oxygen from our atmosphere being transported to the moon via magnetospheric ions. Not a lot of oxygen, but just a little bit. So it shows a little bit how our Earth's magnetic field is actually affecting our nearby neighbor. Really, really interesting mission, and of course, much more recent. So it kind of had an everything all in one. But a spacecraft with a spacecraft and a spacecraft does does very much
Rus- Russian nesting dolls of spacecraft.
yeah, or Japanese nesting dolls, I
Yes.
suppose. But it was very, very successful, and I'll just give you a little bit of a shout out. The nickname Cayuga was one that was selected by the Japanese public, and it is the name of a lunar princess from an ancient Japanese folktale. So if you feel like reading up a little bit of fun mythology, that's what to look for.
Yeah, and you'll come across some fun what are those called? Wood. Oh
Oh
gosh.
yeah, the wood cuttings and engravings and
Yes.
stuff.
Yeah. Some beautiful century old plus Japanese art.
Yes, and my apologies to JAXA. I'm sure I have been saying Kaguya wrong several times. I keep getting the words mixed up when they try to come out of my voice, but it is a really fun mission, of course.
Another cool thing is that they collected names and messages that were
Oh yes, yes they did.
carried through the Wish Upon the Moon campaign.
Yeah, and this is not the first or last mission to do this. It's very, very popular, I would say now, and a nice way to kind of include more members of the public in what you're doing with science is allow people to put their names in, so that they can be either engraved or in this case they were printed on a very small sheet,
Very small sheet of paper.
at in a size of 70 micrometers, which is it
Just
would
very,
be
very small.
illegible, but it's a
Yeah.
very, very nice idea. But that's how you get 412,000 names on one small piece of paper.
I'm
You just
amazed that you have like how good a printer
yes,
do you
this
have that
that
like
at
because you'd need
70
a microscope
microns.
to read that, right?
Yeah,
Or do you just kind of go, yeah, yeah, it's there, we promise.
yeah, it would be putting um 10,000 um zeros in 1 inch. I suppose that would be the way to put it.
Yeah, that's a
Typing 10,000 zeros in a size of 1 inch.
that's tiny.
That's yeah. But anyways, so moons are good for lots of things, and obviously, having missions that can impact your moon will provide you a lot of extra information about the material, the magnetic field, or in this case, even the gravity.
Yes. Now we move on to a moon that's shaped like a potato.
Ah, yes, classic, the potato moons.
The potato moon. Um, so we are going to September 16th, 1848, and the discovery of Hyperion, which is also known as Saturn 7. It's the eighth largest moon of Saturn. It is highly irregular in shape. It is shaped like a potato. It has a chaotic rotation, low density, and although it's shaped like a potato, it looks like a sponge. It's full
How
of
does that
holes.
work?
It's full of holes. So,
Oh,
like,
like the animal.
yeah, like
The
the
animal, not
animal,
the not the
not the
kitchen.
plasticky thing that you find in the, brightly colored in your kitchen. I mean, you might have a natural sponge in your kitchen, but why? Um, so it was the first non-rounded moon to be discovered. It was independently discovered by a couple of days apart by William Cranch Bond, along with his son George Phillips Bond in the US, and William Lassell in the UK. In Greek mythology, Hyperion was the Titan of watchfulness and observation, and the older brother of Cronus, who is the Roman or the Greek version, the Roman version being Saturn. The discovery came shortly after John Herschel's suggestion regarding the names of the seven previously discovered moons around Saturn. And though Lassell saw the moon 2 days after the Bonds did, he published first and followed Herschel's naming convention, which he had already endorsed. So, Hyperion. It's one of the largest irregularly shaped bodies known, second only to Neptune's moon Proteus. The largest crater is a bit larger than 120 kilometers in diameter and a bit over 10 kilometers deep. So this is a really big crater. Um, it may be the moon itself, may be a fragment of a larger body that broke up long ago. An ejecta from that breakup, the breakup of a proto Hyperion, would have impacted Titan at low speed, building up volatiles in Titan's atmosphere. It's low density, so like Mimas, largely ice water, very small amounts of rock, not ice water, sorry, water ice. Get that. Got to get those words in the right order.
Although, I mean, you could say ice water in this case too. It's technically accurate. Um,
Well, it's solid though. So water ice rather than ice water. Um, it may also be like a loose accretion pile of rubble in consistency. It has a low albedo, so it has some sort of dark material covering it. The Cassini flybys resulted in the following knowledge. The surface has deep, sharp edged craters with dark material at the bottoms. That material contains long chains of carbon and hydrogen. The sponge like appearance is due to its low density, so impactors would squish the surface rather than excavate it. And any material that came off in those in impacts um, is very unlikely to return to the surface because its surface gravity is so low. It is about 40% empty space. And its surface is electrically charged. And so far, it's only the second moon after our own to be known to have a charge at its surface.
oh,
And
interesting.
yeah, another weird thing about it is that it is not tidally locked with Saturn. And it's the only regular planetary satellite in the solar system not to be. Uh,
Excellent.
yeah, she's just a weirdo all around this planet, this moon. Its rotation is unpredictable and its orbit is more of a zone than a single path. Like I saw like an illustration of it. I'll share it in the chat. You see it shows like Saturn and then Titan's orbit and then the orbit of Hyperion looks like someone's playing with a spirograph.
Awesome.
Yeah.
Yeah, and this is, I mean, really chaotic by all, accounts. Just unusual, irregular, everything, shape, density, orbit. It's all just all the rules were thrown out. It's not following what anybody says, and it's probably gonna crash into something at some point.
It's like march to the beat of my own drummer. Thank you very much.
Yeah, and the interesting thing is, as you say, the strange properties of it, the fact that it has a low albedo, which is a darker color, and then it's got this incredibly interesting, porous nature where there doesn't seem to be, you know, stuff in there. Like there's literally holes or voids in
Yeah,
the
looking at
moon.
photos, it really reminds me of like, close-up pictures of like pumice or something, right? Like,
Yeah, and then you wonder, like, what happened to get rid of all of its volatiles, or some of its volatiles, and maybe they evaporated off at some point, or and I mean that's as you say, there's some talk about maybe it has had some interaction that caused it to gain a charge but lose some material.
yeah, so cool.
Yeah, and I mean it's always wonderful when you see more of these mystery objects, but if I have to be honest, I am pretty glad this one is not around Earth.
I mean,
It's too unpredictable.
fair, fair.
It might well crash into us, and that it does seem like a bit on the large side for Earth impact.
Yeah, yeah, no, no, thank you.
So we'll admire it from a distance and hope that Saturn doesn't like throw it at us at some point.
Yes.
um,
All right. So reminders for the week. We've already mentioned that Ryan's up at
yes,
Killarney.
official astronomer in residence this week, Ryan Marciniak, starts today. Apparently has beautiful clear skies. But I believe his first public show will be on Wednesday. So if you are going camping at Killarney this week, make sure to check it out.
Nice. Okay.
And the other update was usually we have in-person tours every Wednesday. However, this particular Wednesday, we have the Rask Toronto Centre Speakers Night, which means we will actually be following along with Rask Toronto Centre on YouTube on Wednesday, September 18th, and that link is on the website. So if you want to follow along, go to the link on the website, but don't come in person because we'll all be at the talk.
Okay. Awesome. Uh, New partnerships, new locations for Rask TO. Huzzah.
Yes, they are at, actually, that should be part of the announcement, I suppose. So Rask Toronto Centre now meets at York University with the Allan I Carswell Observatory. Usually every first Wednesday, but this has been a little bit of a an interesting month.
You
But
know,
we also have the speakers nights online with them. And we may even be getting the dark sky meetings as well. So all the more reason to come to York University and enjoy the observatory on campus if you're around.
awesome. I promote the observatory every chance I get.
Well, there'll be even more chances in October because we're going to start our fundraiser. So look forward to
Nice.
that, everyone.
All right. Let's hop into the news.
Yeah, absolutely. Do you want to go first or second?
No, you go ahead.
All right. So news items. There's so much news happening. I thought I would just keep with the theme of moons, and there's a lunar eclipse tomorrow. So
Huzzah!
I can't imagine anything quite as newsworthy as a lunar eclipse that yes, you, might be able to see. So if you're in North America, and in particular if you are on the East Coast, you'll have a fairly good time of seeing the partial eclipse tomorrow. And I just want to give a little shout out. The partial eclipse, the partial lunar eclipse, I should say, from Toronto, starts as what's called a penumbral eclipse on September 17th at 8:41 p.m.
That's really good
However,
timing.
it is, however, unfortunately, penumbral eclipses are very, very, very hard to view. So Earth's shadow, and this is always one of my favorite things to imagine. So you have the moon in the sky at night, and it's shining, white, and it looks full. And when it's like that, you just have to remember that it's because there's this giant light behind you in space on the other side of our planet shining where we can't see it in the nighttime, right? So on the daytime side of Earth, that's being all blasted by the sun, and that sunlight is going past Earth and hitting the moon. Now, it's going past Earth and it's hitting the daylight side, but that means the nighttime side is casting a shadow. And the shadow that the Earth casts has two parts. It has a dark part called the umbra and a less dark part called the penumbra that's a little bit bigger. And if the moon's lined up just right, it starts to move into that shadow area. And when it gets to the penumbra, what happens is the moon just gets a little dimmer, just a little bit dimmer, and you might not even be able to notice it if you're in the city. It's a very, very faint effect. But if the moon hits the umbra, the dark part of the shadow, then a lot more of the light from the sun is blocked and it looks like there's a shadow on the moon. And that's what's going to happen in this partial eclipse. So only a tiny little piece of the moon will actually go into shadow, and it's going to look a lot actually like a Death Star. So it's going to look not so much more than my Mrs. Giant, giant cousin, because there's going to be a little tiny
A
shadow
little nibble.
divot coming off of the top of the moon. And what's going to happen is that little tiny bite will just get a little bit bigger and then a little bit bigger, and then it'll start to get smaller again. And so if you go out and try to catch a picture, what you want to do is wait until what they say the partial eclipse begins. And that doesn't happen until 10:12 p.m. tomorrow on September 17th. And that bite will look really, really tiny. It might just look like the very, very edge of the moon is missing on one tiny corner. And then when you get the maximum bite, that's the biggest little sort of divot that the shadow is going to take out, that's going to be at 10:44 p.m. So if you want to get a picture where the moon looks the most like the Death Star, that will be at 10:44 p.m., which is still actually not that bad of a time to go and look at the moon.
It's really
Um,
respectable.
really respectable for astronomy. And the whole partial show will end at 11:15 p.m. And you can stay awake longer for the end of the penumbral eclipse, but like I said, it's it is very, very hard to see naked eye. The effect is extremely subtle. So the only pictures I've ever seen where people were able to get a good view of a penumbral eclipse were places like, of course, Killarney Provincial Park on an extremely dark night, where the subtle, subtle effect of just having the moon be a little bit darker over part of the moon is actually viewable. So this is all happening tomorrow. Very, very exciting. And it is a lunar eclipse. And it's not even going to be the best lunar eclipse, but it is going to be some excellent practice because next year, in March of 2025,
Hmm.
there's actually going to be a really excellent lunar eclipse. And this is the one to practice for because this
Yeah.
one will have the entire moon passing into Earth's umbra. And this is where the moon will turn very, very red. And unlike that pesky solar eclipse we had earlier this year, for a lunar eclipse, everybody on the dark side of Earth basically gets to see it. So you won't have to drive to Niagara Falls or anything. You'll all be able to see it from
Don't
your
need any special
backyard. No
glasses.
special glasses needed. Very easy.
Yeah.
All we need is clear weather. So knock on something. And the other bad news is that the really, really good total lunar eclipse in March, it does start a little bit later. So
Yeah.
you do actually
Just
have to
before
stay.
midnight.
Yeah, it's you do have to stay up past midnight, and you really need to be awake until about 2 o'clock in the morning if you want to get the full show.
Yeah.
But it's going to be spectacular and it should be really, really fun. So I highly advise people to attend the practice eclipse tomorrow. See if you can spot it. Maybe get some cool pictures and keep in mind the total lunar eclipse coming up in March.
Yeah.
And it is interesting, of course, because it's worth noting that these eclipses are all part of what are called eclipse seasons, because eclipses don't generally happen by themselves. You tend to get pairs of lunar and solar eclipses. So in this case, we have, the eclipse season. This is actually the first eclipse of this particular eclipse season is tomorrow. The second eclipse will be the one on October 2nd, which we won't be able to see uh, anywhere from Canada. It's in an annular solar eclipse that's traveling through, I believe, South America. But that's the companion to this eclipse. The third eclipse is an almost lunar eclipse, which is on October 17th, and that's part of the same eclipse season. So you can have two eclipses in a row, sometimes even three eclipses, all during the same what are called eclipse seasons. And this is where the Earth, the Moon, the Sun tend to line up. And this is, you have to just remember the Moon is going around the Earth, but it's not going in quite a circle, and it's not going at quite the same angle as everything else. So there's all these little offsets. So to
Yes.
get it to actually line up, the sun, the moon, and the earth all have to be in a line, and that happens when the moon is on one of the nodes of its orbit. So um, we won't quite have a perfect alignment for this eclipse because it is a partial, but it should still be fun and in reasonable skies, and if it's not too cloudy, you'll get to see just that little bite getting taken out of the moon or appeared to get taken out of the moon during a very, very reasonable time tomorrow evening.
Nice. My astronomer who has a day job pro tip for the March total eclipse is set an alarm for totality. When it goes off, you open an eye, look out the window. If you see clouds, you roll over and go back to sleep. If you see clear sky, you go look at the eclipse.
Yes, and I mean, if you're going to set up photography cameras as well, you can wait until, 30 minutes to an hour before totality and just sort of wake up for the event. Or you could even tune in to one of the telescopes that are streaming the images from the eclipse live on YouTube, which we might try to do again this year. I
Amazing.
mean, next year when it happens.
Yes. I mean, it's
Next
this
total
school
eclipse.
year.
That's true. And it is not a little bit confusing that the school year runs from September through April. Um, whoever made that call, I don't
Well,
understand.
you know, it can't be Australia everywhere, I guess.
Yes, unfortunately not. Um, as, not everywhere can be a tropical paradise.
Although everything tries to
Um,
kill you in Australia, so
and the moon is upside down,
and the
so
moon is upside down. I mean, there's no up or down in space, but okay. Um, we are not leaving the Earth for this, but we are talking about a more different moon. What, Julie? The Earth only has one moon for now.
Whoa.
There's a new study in the research notes of the AAS that shows that a small asteroid will be pulled into Earth's orbit between September 29th and November 25th. And so it will become a mini moon or a temporary moon and then leave Earth orbit and go off to other parts of the solar system. The object is known as 2024 PT5 because astronomers are really bad at naming things.
That's true.
We're so bad at it. And it's 10 meters wide. This wee little thing. So you're not gonna go outside and be like, oh, look at the two moons. Um, but it'll be out there. This is not entirely unusual. The Earth does this to small asteroids from time to time. The asteroids get pulled in for a partial or full orbit before being flung away. Another example of temporary mini moons is the object 2022 NX1, again, terrible naming, um, which was here in, you would think 2022, and it was, but also in 1981. 2024 PT5 was discovered in August by the Asteroid Terrestrial Impact Last Alert System, which I'm glad we have that. It's likely to be a fragment of the big moon that we have. Um, when it became a fragment of it, I don't know. The article I read did not include that. Um, Homework for me. Its current size, speed, and path were followed by the scientists to predict a path for the next few months. So it's expected to follow a horseshoe type orbit and then return to its orbit around the sun, and it'll be back in 2020 and 2055. The researchers suspect it comes from the Arjuna asteroid belt, which is a belt of small near Earth bodies orbiting the sun in the same area as the Earth Moon system.
So cool. And it just goes to show there really is so much stuff out there. The
Stuff.
question of what gets counted as a moon and what doesn't, Mars, um, Phobos and Deimos. But I mean, we have things in orbit at the the Trojans, which are occupied gravitationally stable points, like the Lagrange points. So out by James Webb Space Telescope. There's a couple little things out there.
Stay away from
um,
our telescope, okay?
yeah, one of them actually impacted JWST early
Oh,
on, scared a lot of people. But we get these small things, little tiny asteroids, little Trojans that go in around Earth, and like you say, some of them are temporary, some of them follow Earth for a little bit. Sometimes they're called quasi-satellites. Sometimes they have all kinds of weird things, and of course, we have now like what, 20,000 artificial satellites?
yes, so many. Actually,
Um,
I don't know. I don't know that anyone knows how many there actually are.
yeah, and I mean, there's been so many false detections. There was a very famous one back in 2015 where they got really excited about a new moon, only to realize it was actually the Gaia Space Telescope. Um,
Oh my goodness.
oops.
That's hilarious.
Yeah, so if you want to know how many moons Earth has, there's one that we call the moon, and then there's other stuff, lots and lots of other stuff. But there's always just so much space between everything that, it's actually a real challenge to map out.
Yes. Space. It's vast and Yeah, full of stuff.
Yeah, there's so much out there. So many things, so many asteroids, so many little mini moons, so many crazy interesting things, but then also just more so much more just empty space than there is all of that stuff.
It's true.
But in any
Questions to
case,
answer till the end of time, Elena.
exactly. And if we didn't like poking around and having the mystery, then we'd be in the wrong job.
Exactly. All right, everyone. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Dr. Elena Hyde and myself, Jeannie Tomei. You can always connect with us on Instagram at the handle at York U Observatory and on Facebook at Allan I Carswell Obs, or check out our website for show notes, content, updates, and contact info, et cetera, et cetera, et cetera, at www.yorku.ca/science/observatory. Thanks for tuning in. Clear skies and have a good night.